So equations and lines we're going to show you. That's kind of that second to last formula. And then we're going to do the planes, which is the very last formula. And the worst thing you have today, there's more cross product involved. I know, get excited about that. Now here's where I wish we had color-coded notes here, so you can kind of see that red line shows up a little bit better. So a line in three-dimensional space. So you're going to have a point, and again, three-dimensional space, x, y, z, so you can see the point labeled there on the line. In 3 dimensions, direction of the line described by a vector parallel to L. Now, I know it sounds crazy. We are back to, in order to find the equations, we're back to using those parametric equations that we did in the previous chapter. Now we're just going to take a look at them. They're going to be in 3 dimensions. So we're going to have x, y, and z. Last chapter you just had x and y. So if you look, of course, I think these are pretty easy. Line passing through the point and parallel to the vector, described by these equations. Now, I always think of the vector is what moves the point. Moves it left or up, right and down, so on and so forth. The vector moves the point. So you are starting at the ordered pair in the point, and then the A comes from the vector. B is from the vector. C is from the vector. You add on the movement of the vector. So this is as wild as it gets. Find a parametric equation for the line passing through the point and is parallel to that vector. So we're going to have, of course, our 3 equations. Last chapter we only had 2. We just worked in our 2-dimensional space. So really, we're just going to start at the point. So my first coordinate is 0.5. And then, like I said, I think of it as you're applying the vector to that point. So, of course, I'm looking at the 3. So I'm going to have plus 3t. For y, I'm going to start at the y coordinate of the point, -2. And I'm not putting plus -4. We're going to, of course, apply the vector. So I'm not going to write plus -4. I'm just going to put minus 4t. Start at the point, z coordinate of the point 3, apply your vector, which is 2t. And that is it, my friends. I know, too easy after yesterday's crazy, ridiculous cross product. Now, the next one, still easy, smidge more work. Because here's the difference. Find parametric equations. They didn't give you the vector. Big deal. We know how to make vectors, so I'll make the vector first. So I'm going to use my component form. If it doesn't specify, I never use I, J, and K. I just find it obnoxious. So, of course, from the points, from -1 to 2, how did you move? 3. We know how to make vectors. From 2 to -3, you went down how many? And then from 6 to -7, you went down how many? Got it. So you might have to make the vector. Who cares? Okay. Now, we've got 2 points. For our equations, it doesn't matter which point you use. I might pick the first one. I don't know. Probably just to be difficult. Owen might pick the second one. Same thing. So I'm just going to use the first point. I'm just going to kind of circle it here so you know. So remember, you're starting at the point. I'm going to start with the -1, and then we apply the vector. For y, I'm going to start at 2 and apply my vector. Z, I'm going to start at 6 and apply the vector. And again, you could have, I don't care, you could have used the other point. You could have 2 in your vector. You could have, of course, -3 plus, why am I putting plus -5? I don't know, -5. Or, of course, you could have started at -7 and applied the vector. So I don't care if you give me the red ones or the green ones, it all results in the same line. Any questions on that? We're halfway already. Flip it over. Home stretch. Now, still easy, but we got to kind of some vocab here. A lot of vocab. Look at the picture. That's really what we're going to look at. So a line in space is determined by a point and direction. Okay, we know that. We apply our vector to it. We just did that. You had your point. We applied the vector. That's what we're talking about. We're going to start talking, and we've done perpendicular vectors. Remember, perpendicular vector is just using or making the cross product, for the record. Now we're going to get fancy. We're going to get fancy. With our perpendicular vector, we're going to call it the normal vector. I know it gets a little fancy name, so catch that, because they're going to use it in the formula coming at us here. So determine if it's in the plane. We of course check to make sure that it's perpendicular to the vector. So now what they're doing in your three-dimensional space, your x, y, and z, we're going to find the equation of the plane in our three-dimensional space. Well, to do that, of course, we need a point, any point on the plane, okay? And you need your normal vector. So again, I kind of think of it as you're applying the vector to the ordered pairs. B is part of the vector to the points. C part of the vector to the points. So we're going to go through and show you how to find an equation of a plane. It's pretty darn easy here because they're going to give you the normal vector and the point. So again, I start with the vector, of course, for our first coordinate. Now we're looking at x here. So just looking at our formula, I'm going to have x minus 3, y minus, what's the y coordinate, whatever the y coordinate is, z minus the z coordinate. So just fill it in, x minus our x coordinate. Okay, for our y vector, -6. And then y, I'm not putting minus -1, let's just make it plus. Our vector, and then z minus, well, let's make it plus, equals 0. Now, there's the setup. Of course, you know, we need to simplify, distribute, combine any like terms, blah, blah, blah. We can all distribute. And I'm just going to clean it up. So when we write our equation of the plane, of course, as always, even when we do our vector, when we do it all, x, y, z. So that's how the order I want terms on my left side. I want x, y, z, and I'm going to shove whatever numbers onto the other side. So I'm going to leave it 4x minus 6y plus 3z. So I always want it in that order. I'm looking at the constant terms here. I've got -12. So I'm at -18 now. Well, okay, the 6's cancel. So I'm just going to cross those guys off. And I'm going to move the 12 to the other side. So there's my equation of the plane in three-dimensional space. Now it asks for intercepts. Okay, intercepts easy. Intercepts are the same rules there are for a line, for anything. If I need an x-intercept, of course, y and z would be 0. Probably mental math that. You need a y-intercept, x and z are 0. Z-intercept, x and y are 0. Okay, let's do the x-intercept. So, if I'm going to do the x-intercept, I would put zeros in for the other two letters, or really those terms cancel out. You'd be left with 4x equals 12. 3. If I'm going to do the y-intercept, I'm going to put 0 in for the x and the z, so you're down to -6y equals 12. And last but not least, what's your z-intercept? 4. Got it. That's as wild as that gets. Any questions on that? And I just wrote the values for the intercepts. I don't care if you write them ordered pair style, like you could put 3, 0, 0, 0, 2, 0. I just find that obnoxious, but you're welcome to do it. All right, final problem of chapter 9. Are you sad, happy, sad, a little bit of everything? All right, find an equation of the plane, okay, so like we were doing in the last problem, that passes through those points. Here's the difference. They got the points. We don't have the vector. We need the normal vector. Now, here's where it gets fun. Normal vector, okay, is orthogonal or perpendicular. To make it perpendicular, we have to do the cross product. That's why I put the cross product formula up there for us. Okay, so let's start with it. So of course we want to start with our vectors from the same initial point. So we're going to make vector PQ, and I'm going to make vector P to R. So first mission, we're going to make our vectors. So we can all do that. That's pretty simple. So P to Q, 1 to -2, down 3, 4 to 5, up 1, and then 6 to -1, we went down 7. Now I'm going to make vector P to R. Okay, all right. Oh, I like this. 1 to 1, 0. Always happy to see a 0. It makes less calculating. Always makes my day. Okay, from 4 to -1, down 5. And of course, 6 to 1, down 5. Okay, so there are vectors to make an orthogonal or a normal vector. Maybe you're already calculating it. I couldn't even fit it all in one line. We have to go through and do the cross product. So that's your next mission here. We're going to do the cross product of PQ and PR. So I'm going to give you a second to do the math on that. Let's see what you get. You do get, I don't want to say they're like huge number, but it's kind of some bigger numbers. Yeah, you might want your calculator. So you're doing the A2B3, A3B2. It's so fun. So fun. How horrible would it be if I didn't give you a formula sheet this chapter?
Probably did like less than 50.
I'd probably cry myself, Dale. Because I always, even this cross product, I mean, like, I'm pretty sure I got memorized, but I always look at it. It makes me paranoid.
This is awful.
It is kind of. So you're doing the cross product right now.
I haven't even wrote all those.
Just checking them out. Oh my gosh. That is correct. I don't know what's happening over here. I know. That's why I'm just like jealous. Okay, Elliot. Oh, I can take that. I can take that. How's our cross product coming? Pains me to say it. Owen's right.
Dang it.
Oh, yeah. I did not think I got that right.
Now, if you've got your cross product, you can make your equation of the plane. Pick one of the points.
Oh, is it -4?
I don't know.
15, 15.
I don't know.
Okay, so that wasn't my question. I don't think
All right, I see we're getting the cross product. You should have -40, -15, 15.
you're so helpful, Owen.
Okay, good work on that. Thank God for a formula sheet. Now, it does not matter which point you pick to make our equation. So now we're kind of at this point here. We've got our vector, our normal vector made. I'm going to be super lame and just use the first point, and I'm going to plug it all in. Okay, so I'm going to use, I should have not written all over it. So I'm going to use the 1, 4, 6. You can use a different point if you want. Clearly, I don't care. All right, apply your vector first. Then we're going to have x minus our x coordinate. Then I'm going to apply the vector, y minus the y coordinate. Apply my vector of 15, z minus 6, and we equal 0. All right, now I'm doing the work. I'm distributing. I'm going to put it in x, y, z order. It's going to be very exciting. Not really. Okay. I'm going to put it in order. I want x first, y, and then z. So I'm going to leave my -40x, my 15y, my z. So always just make sure you have it x, y, z, of course. Let's total up our constant terms. So 40, 60, I'm at a hundo. 100 minus 90, I'm at 10. But I want to move it to the other side. So what are you going to equal? Yeah. Now, I have 0 problems if you leave your equation like that. Obviously, I could care less. You could make it even a little simpler. I love our dedication method. Yeah, that's good. God almighty. You could divide everything by what? 5. If you want to reduce it down by 5, you're welcome to reduce it by 5. Or I guess take that, yeah, that's good approach. I'll just circle it because apparently that's good. All right. Any questions on that?